Assalamu alaikum and good morning, everyone. I welcome you all to the technical session number 1 of this first International OBE Symposium. Our session chair for technical session number 1 is Professor Muhammad Mahbubur Rahman, the Vice Chancellor of Ahsanullah University of Science and Technology. Before handing over to Professor Mahbubur Rahman, allow me a few minutes to introduce him to the audience. Professor Mahbubur Rahman is a Commonwealth Scholar and McNamara Fellow. He has taught architecture and at various universities in various countries since 1985. That includes the Kingdom of Bahrain, where he was also the Dean of the Faculty of Engineering and Design in the Kingdom University. Professor Mahbubur Rahman has wide experience in engineering program design, accreditation, and quality assurance. On the other hand, his research work includes publication of over 100 papers in international journals and conferences, and authoring 6 books. Professor Mahbubur Rahman regularly contributes to government and civil society committees and acts as a resource person and advisor to government and international bodies. Now, I kindly request Professor Mahbubur Rahman to conduct this session. You need to turn your microphone on, Prof. Professor Mahbubur Rahman, your microphone is muted.
Yeah, sorry, my apologies. I was on mute. So I'll start by welcoming you all. First of all, thank you, Dr. Al-Sheikh. And then I welcome you all to the technical session number 1 on the International OBE Symposium arranged by the Ahsanullah University of Science and Technology. In this session, along with the coordinator, we have Dr. Al-Sheikh of UNICAL, whom you already have met as the rapporteur, and the 2 distinguished presenters from UKM. And of course, the coordinator, Minhazul Khan, who is just behind me, hopefully. And both these presentations would be, in this session, are related to engineering education. Before introducing the presenter number 1, I should like to mention that each presenter will get up to 30 minutes to make their presentations. And following that, we'll have a 15 minutes session or time for question and answer. The first presenter on an overview of Washington Accord requirements will be made by Professor Shahriar Abdullah. Professor Abdullah received his PhD from the University of Wales, Swansea on computational fluid dynamics. He is with the Department of Mechanical and Manufacturing Engineering at UKM, Malaysia, where he was also the first director of the Center for Quality Assurance and the Dean of the Faculty of Engineering and Built Environment. Professor Abdullah is also the founding president of Malaysian Higher Education Institutional Quality Assurance Network and was the AUN QA Council member representing Malaysia. He served as a program and institutional assessor for many parties, including the Malaysian Qualification Agency, the Malaysian Engineering Accreditation Council, the AUN QA Program and Institutional Assessment, and the ASEAN EU Share Projects. Professor Abdullah currently holds several positions related to quality assurance at the national and international levels. For example, the Deputy Chair of AUN QA Council, the Chair for the Strategic Planning and Strengthening of the National General course modules, an expert on the Malaysian qualification framework and outcome-based education, and member of the working committee for the ESE Standard 2020. With that, I would like to invite Professor Shahrir Abdullah to deliver his presentation. Professor Abdullah.
Thank you very much, Professor Muhammad Mahbubur Rahman, for the introduction. And also I would like to thank the organizer, Asanullah, University of Science and Technology, UST, for inviting me to deliver the first presentation about an overview of Washington Court requirements. So without further ado, I will start my presentation, and then my presentation basically is based on the documentation issued by the court itself. So this is my outline, the outline of my presentation. I will cover Western Court plus several requisites, including graduate attributes, knowledge profiles, criteria on complex problem and complex activities, as well as some brief explanation on professional competences and conclusion. So let me start with the introduction about Western Court. It is a multilateral agreement originally signed in 1989 between bodies responsible for accreditation. Sorry about that. Bodies responsible for accreditation and then targeting for tertiary level engineering qualifications within their jurisdiction who have chosen to work collectively to assist mobility of professional engineers. Basically, this is taken from the document itself. And then together with the Washington Accord, there are also two other accords. Sydney Accord signed in 2001 and Dublin Accord signed in 2002, where all the accords are committed to the development and recognition of good practices in engineering education. But of course, each accord has their own domain. And then up to date for Western Accord, there are 21 full signatories, or we can also say it as countries, and 7 provisional signatories. And then the documents on Western Accord target actually to explain 3 stages of development of engineering professional, starting with the graduate stage, which are obtained upon attainment of accredited educational qualification. And then by the point of graduation, the graduate should have been equipped with knowledge base and attributes to continue learning. Then after a few years being in the working life or in the employment, then the graduate is expected to undergo a period of formative development under supervision of a practitioner, and then apply for professional registration. During that process, the graduate is expected to take from the assisting role to be more individual and to undertake team responsibility. And then, of course, we target for further after getting the professional registration. Then the individual should target to maintain and expand the competences in order to qualify for an international register. So these 3 stages is explained in the documents. And then since we have 3 accords, in order to compare with all the 3 accords and then to identify the differences. So first I would like to show Western Accord. For Western Accord, it is for engineering program, for academic program dealing with the practice of engineering at professional level. And then it is about solving complex engineering problem. For Sydney Accord, it is dealing with engineering technology, and then the type of problem can be categorized as broadly defined engineering problem. It is also a degree program, while do blanket targets for engineering technicians in order to solve well-defined problem. Normally, it's a diploma program. So in my presentation, as I said, is basically is taken directly from the documents. This is the document. Of course, this is the previous version. The document is the previous version, issued in 2013. But just now we heard the chair, the organizer said that it was updated, and then now it is updated to the If you go to the website of International Engineering Alliance, you can get a later version, just approved in June this year. Of course, there are many updates has been introduced in the new version, including mainly the engineering the version record documents address the requirement for 17 Sustainable Development Goals. So those are available in the IEA website. So one of the important elements that I would like to touch is about the graduate attributes, because this has been used as a pillar for all accreditation process involving engineering education. So as stipulated in the version code, graduate attributes form a set of individual accessible outcomes. So I emphasize on individual accessible outcomes in form of blue text here. And then that are the components indicative of graduate potential to acquire competence to practice at appropriate level. So the graduate attributes also are exemplars of attributes expected of a graduate from accredited program, composed of clear or succinct statement of expected capability. So normally these statements are called program outcomes or program learning outcomes, and also serve to identify distinctive characteristics as well as area of commonality between expected outcome of different type of programs. So if we compare different type of engineering programs within the country, even within the institution, there are some similar characteristics that must be maintained, especially when dealing, if it is related to generic skills or soft skills. Also, this graduate attribute does not in themselves constitute to an international standard for accredited qualification, but provide a widely accepted point of reference or benchmark, so that the outcomes can be substantially made equivalent to many programs. Okay, of course, the graduate attribute itself cannot be a standard, because the standards, the quality standard has to cover beyond that, more than that. So from these features or these characteristics, we can say that the graduate attributes are accessible outcomes supported by level statements such as program or course outcomes, for example, developed by signatories as statements of learning outcomes, program learning outcomes or program outcomes that give confidence to the educational objective of program being achieved. So in this case, you can see this statement also point out that there is another higher level statements of graduate attributes, which is referred to here as educational objectives. But of course, in order to evaluate the quality, we need to have a bigger spectrum in order to ensure the program is achieve some criteria that can assure quality. So the quality of the program depends not only on the stated objective and attributes to be assessed, but also the program design, resources committed to the program, the teaching and learning process, and assessment of students, including confirmation that the graduate attributes are satisfied. And then the latter phrase here, it actually refers to CQI, continual quality improvement. So let's examine in a more detail about the graduate attributes. And in this case, as I mentioned before, there are two versions that I would like to refer to because the earlier one, which was issued in 2013, because many of us still referring to that, and the latter one, the most recent one, 2021. Maybe this one is the standard, the country or national standards will be updated in the near future. So in order to understand this, I'm not going to read one by one here because it's quite wordy, but try to look at the distinctive characteristic that differentiating between both versions. So in this case, the graduate attributes, there are 12 or 11 to 12 graduate attributes, starting from the knowledge. The first is engineering knowledge, which target to address the solution of complex engineering problem. Okay, and then you can see the engineering knowledge, the earlier version, the 2013 version, we have a statement which is updated to include some latest feature. Basically, the reason of these updates, actually, there are two main reasons. First, to respond to the 17 United Nations Sustainable Development Goals, and then to update the attributes along with the evolution of the discipline itself. For example, now we are facing the challenges due to fourth industrial revolution. So in this case, the first graduate attributes has some added terms here, computing. The same goes to the second one. If we compare the previous version with the latest version, there are elements of sustainable development goals is added as given in the blue text here. The others should be the same. So in this case, the blue text here may be of interest of the program or curriculum designer to take into consideration for a future curriculum review. So this is the first two graduate attributes. Secondly, in the second slide, basically the third graduate attributes is about design and development of solution. You can see here, there are some updates to include aspect like whole life cost, net zero carbon, as well as resources consideration. And there are some escape clause here. This consideration can be considered as required, depend on the project or depend on the topics handled or addressed by student. Okay, at the same time, I also make some colors here. For example, the red one here is to highlight the complex engineering problem that has been the main criteria, one of the main criteria under graduate attributes, as well as the green color, which represent the updated some minor changes. For example, in design and development solution, the term specified needs has been changed to identified needs, some minor or minor changes. The same goes to the fourth attributes, that it doesn't have much changes except the rewording, the rearrangement of words inside the same attributes. Okay, and then moving on, for the fifth attribute, there are also some updates even on the domain. The previous one is called modern tool usage, but the current one, the recent one, the word modern is dropped. So we only have tool usage. Same goes to the colors here. You can see there is a new color, magenta, purple, which represent the term that is dropped. But you can see here, the blue color is the one that has been updated or added. The one that has major revision here is on the 6th attribute, where previously we have engineering and society. Those the whole sentence has been reworked to add the address on 17 United Nations goals. At the same time, to make emphasis on sustainability and sustainable development, as well as economy. And then the domain also changed to engineers and the world to address, to bring in globalization issues. Okay. So in this case, since the sustainability or sustainable development has been covered in the 6th attribute under the new revision, the 7 attributes, which is originally in the 2013 version, has been dropped entirely. So you can say that the element of environment and sustainability has been embedded in the 2nd and 6th attributes. For ethics, it is some updates to include the international law and to include the need for diversity and inclusion. And then for teamwork, individual and teamwork, roughly it is the same, except the recent one has been updated to include collaborative teamwork as well as online and distributed setting, the collaboration done in online and distributed setting, in line with our current working mode in the new normals. At the same time, you can also observe the ethics and individual and collaborative teamwork has been attached to WK9, which is a new one actually. The WK9 is not present in the previous version. Okay, moving on, for grade attributes, there are also some updates on communication to include inclusivity, inclusive interaction within the teams among the graduates or the students. Okay, and then project management and finance, only some work has been updated from demonstrate to apply. There's not much changes on that. And also for lifelong learning, you can see here, apart from the change in some words, there are also some new context has been added, which is highlighted in blue here: adaptability to a new emerging technologies and critical thinking. So these are all the updates that has been introduced in the new version. Okay, moving on. So in order to deliver or to obtain all these attributes, you need a curriculum. The curriculum actually is defined by a knowledge profile. So what is knowledge profile? Knowledge profile under the code is an indicated volume of learning and attributes against which the graduates must be able to perform. It can be also referred to the body of knowledge for the program or the curriculum structure, the framework for curriculum structure. It is a requirement for designing program with different detailed structure, learning path, and modes of delivery. So if you look at the Western Accord credit profile, we have seen also some changes. This is expected because of the graduate attribute also has been changed. The first, for example, the first knowledge profile, you can see the new version at awareness to relevant social science, meaning to say that the future engineering curriculum has to be a bit more liberal to take into to put emphasis on subject related to social science, at least on the awareness on contemporary issues. Okay, and then WK2, the knowledge profile on mathematics, also include data analysis, as we are in the big data era now, as well as some small minor change, some added adjective there, the support detailed analysis. No change for the 3rd knowledge profile and the 4th knowledge profile. And then on the the fifth knowledge profile, it has been reworded, rephrased to be more detailed, to cover all aspects under the engineering design. And then furthermore, the fifth knowledge profile has been expanded, not just limited to engineering design, but to include operation in the practice area. On the sixth knowledge profile, there's not much, not change. And then for the seventh knowledge profile, it is changed, reword to refer to directly the 17 SDGs goals. And then for WK8, the research literature, it has been detailed out further to include awareness of the power of critical thinking and creative approach to evaluate emerging issues. So basically to refine the context on the WK8 on research literature. And then you will notice there is another added WK or knowledge profile, which is on ethics, inclusive behavior and conduct, which has been added to the existing 8. Okay, the rest is similar. Okay, so that is for knowledge profile, where we have the list of components that can be used as a framework for curriculum design or curriculum content. And then on the assessment, since the graduate attributes has to be demonstrated, the elements that has been demonstrated should fulfill should fulfill the criteria for complex problem. So there are elements of complex problem that also been changed in the recent documents. Okay, so but since my colleagues, Dr. Jamri, will present more detail on this, I only just highlight a few things here because I assume he will go more detail on how to deliver complex problem solving as well as complex engineering activity in the curriculum delivery. So you can see here the changes are expected for the second attributes to include the sustainability and other issues. Okay, another thing which is included here is the creativity in the third attributes, and also the fourth attribute has been updated. Okay, and then also the SAMO has been updated in the later version to include collaboration as envisaged by the indicated graduate attributes, as well as some updates on the last attributes for interdependencies. Okay, so that's the summary of the change for complex engineering problem. And for complex engineering activity, while complex problem represent the features or the characteristic of the assignments and projects that need to be demonstrated by students, the complex engineering activity represent the activities, the interactions, the group works, the collaborative activities that has to be demonstrated and undertaken by the students. So in this case, you can also see some updates on certain aspects. For example, the inclusion of analytical and design software, and some element that has been dropped. For example, innovation, the word novel ways is dropped and replaced by innovative solution for a conscious purpose. The others remain the same. So these are all some minor updates on complex engineering activities. But of course, this correct profile, complex problem solving criteria, and complex engineering activity criteria is aimed for the students to attain the graduate attributes at the point of graduation. After the graduation, the graduate is expected to move further to hopefully to register as a professional engineer. So in this case, the Western Accord document also stipulate what is expected for a person to become a professional engineer. So it is a professionally or a professionally competent person that has an attribute to perform activities within the profession or occupation. And it is expected to be able to demonstrate in holistic way at the stages of attaining registration of professional engineer. And then there are attributes that has been detailed out in the documents also, but we are not going to elaborate in this presentation because this presentation is more focused on OBE and the curriculum during the curriculum for the educational programs. But of course, it is there for, if you want to know more about professional competence. And unlike graduate attributes, professional competence is more than a set of attributes that can be demonstrated individually and must be assessed holistically. So if you see the 13 attributes of professional competence, there are, it is actually aligned with the 11 or 12 graduate attributes you can map. But of course, this is not really a focus here in this presentation. So as a conclusion, so I'm coming to my last slide. I would like to give a big picture of how this criteria is related to each other. First, it is a knowledge profile that defines the curriculum structure. Normally, under the in the document, it is said to be delivered within 4 to 5 years, depends on your the entry requirement. For example, if a person completed a standard 12 schooling years, then the curriculum may be designed in the 4 years. And then it is designed based on the 8 or 9 knowledge profile, depending on which issue of national court documents you choose. Then there are student assessment to evaluate the attainment of the outcomes by students, including the culminating assessment or culminating projects such as design projects and final year research project. This has to meet the criteria on complex engineering problems and complex engineering activities, especially on culminating projects. And then the student need to demonstrate the credit attributes. 12 or 11 depends on which edition or which version you choose. And then this to be attained at the point of graduation. And lastly, after the graduation, of course, the program is designed also to have educational objective, and then we expect the attainment by the graduates within the early working life, normally within 3 to 5 years after graduation. And of course, we don't expect the graduate to stop there. They should envisage to go higher to obtain professional engineer status. So these are the big picture of what the National Court stipulates and envisage through the program delivery. Thank you very much for your attention. And I would like to hand over back to Professor Mahbubur Rahman. Thank you.
Thank you, Professor Abdullah, for your and for especially for finishing within time, ahead of time. And thank you for eloquently presenting the difference between the two versions of the Washington Accord, the 2013 and the most recent one, 2021. And now I shall like to open the floor for discussion. If anybody wants to ask any question on Professor Abdullah's presentation, and I will also request you to be brief in your question and to the point related to the presentation only. Thank you.
Okay. There is one question from Prof. Teddy. I'm just reading it. Salam, Prof. If the student did not achieve graduate attribute PA, he cannot graduate, question mark. Or is it as feedback for the program owner, question mark, student can still graduate? Thank you. This is from Prof. Teddy from IIUM Malaysia. He has written, sorry, PO, program outcomes. Yes. If you.
Okay. So, yeah,
Professor
ideally,
Abdullah, I hope you got the question.
Yes, yeah. Ideally, hypothetically, the student shouldn't be allowed to graduate if he or she doesn't meet the outcomes. But of course, depends on the perspective of the accreditation process, whether the accreditation process can exactly capture that. So at the moment, many accreditation process target to pass the student. Actually, not targets, but normally the process now is to pass the student, but to mandate the program to do the CQI on the shortcomings. But of course, ideally, the student shouldn't be allowed to graduate. But since the system in many universities now is still based on CGPA as a gatekeeper to graduate, so maybe the system in the university need to be aligned with the outcome-based system, including the graduation requirements, in order to have that kind of mechanism to be in place.
Thank you, Professor Abdullah, and we'll wait for any other question. But I hope I'm allowed to make questions as well, or
Yes, please.
it's a kind of supplement or complement regarding this question that was raised. I was thinking if the outcomes are aligned with the graduate attributes, and you get the degree when and all the courses are related to one or more of the outcomes. So completing all the required course means successfully completing, you have achieved the outcomes. And that if it's aligned with the graduate attributes, it will mean that you have achieved the graduate attributes as well. So isn't completing all the required courses means you have also successfully achieved graduate attributes?
Okay. My opinion on this, at the moment, the attainment of outcomes is represented by you pass all the course. So, of course, the student need to pass all the course to the graduates. But at the same time, the program attainment is being determined to ensure the student meet all the outcomes. But of course, the system to pass the student in many universities now is not in line with whether or not they achieve the attainment of the program outcomes. But if we can make the courses where the attainment of course outcome in line with the student passing the course, eventually the CGPA, the final CGPA can represent if they pass, or then we can project all the outcomes met. So
thank you. At this point, I'd like to mention or advise that the attendees who have question, they can also write it in the chat box, and we can raise the question for you to the presenter. And we have 10 more minutes for this question answer session. Or you can raise hand as well. Dr. Firoz Alam, I think do not raise hand physically. There is a raise hand button at the bottom of the system. But anyway, Dr. Firoz Alam, please raise your question.
Good morning. I just wanted to compliment to Dr. Abdullah's answer from the Australian perspective. Usually, any student, if they do not complete particular competency or learning, learning outcomes, in that circumstances, student can be, of course, they are not compliant. That's a simple one. Second thing is, sometimes you can, based on the situation, you can give equivalent assessment to achieve or activities to achieve that objectives. That's the one. Second thing is, in most developed countries, the program learning outcome is aligned fully with the national competency standard. And therefore, if any student did not achieve a particular program learning outcome, it means the national standard does not comply. So this is why it is very important that outcome-based learning, particularly the program learning outcomes, if it is aligned with the national competency standard, that is a accreditation body's competency. In Washington Accord, you know that generally 12 competency. In Australia, is 16 competency. We split some of the competencies to avoid some confusion. So that is the thing. So that Professor Abdullah actually mentioned these things nicely, but I just need to be complimented. Thank you.
Yeah, correct. Yeah. There are also a practice where you do the top up for unattained outcomes. But if I can refer to Malaysian situation, it's not been done at the moment because the CQI is focused on the program. Because eventually the student, even though they are allowed to graduate, they are eventually improving the competence through the continuous or lifelong learning.
Again, sorry, I forgot to unmute myself. So this question is from Professor Raisuddin. He is asking, when 50% is the passing marks of individual course, how do we assume he attained the learning outcomes?
Okay, the 50% is actually, I think, is a country based. There are countries implement 60%. But if we use 60% as a benchmark or the cutoff to attain, then you need to look into the instrument whether or not the rubrics align, the rubrics of the attained outcome align with this 50%, or the marking scheme for the test or a question align with that. If you can align, then you can confidently say the student meet the outcome when the marks reach 50%. But of course, I need to tell you that some countries use 60% instead of 50% as a cutoff, or maybe different values.
Thank you. And then, yeah, okay. No, we can wait for a minute or so. We still have 5 minutes, 6 minutes left. If we don't have any new question, we'll move on to the next technical session. But okay, all right then. Can I make 2 more questions? I don't want to monopolize in questioning, but since we are not receiving any new question and since we have 5 more minutes, I'll be very quick. In your presentation, I think you mentioned it twice about the level of student at the entry point. Like you said, the curriculum could be either 4 years or 5 years. Now, does that mean that other than the normal 12 years of high school education that we are familiar with, to define the entry level of the students, is there any other means or way or qualification that the student can enter engineering education earlier than, you know, and do 5 years of take 5 years of education to qualify for the degree?
This is the design. I mean, the design, curriculum design based on the standard schooling years. The recommended one is 12 years of schooling. For example, many based on that schooling years, many enter the tertiary education after finishing A-level, for example. But of course, it depends on the country because many countries may have different systems. There are countries who may have different system in a way that the student quality require 5 years of study. So it's more on country context. But at the moment, Western Accord doesn't accept less than 4 years program.
So the minimum is 4 years.
The minimum at the moment is 4 years.
Okay,
But of course,
thank you.
the
My
individual
other question is
students,
related to
I would
the
give,
accord itself, the Washington
Prof,
Accords.
this is a
Because
design.
there are two or the, and if I can recall that pyramid that you showed at the end of your presentations. After the graduation, a graduate, an engineering graduate, he works towards getting full professional recognition, like 2 or 3 years of practice, and then he obtains a professional engineering qualification with more responsibilities and abilities. Now, so is becoming a full member of Washington Accord, like Bangladesh right now is an tentative, provisional is in the provisional state. Now, so having a system of giving pinch or ensuring, that after graduation and after fulfilling the criteria, an engineering graduate can receive pinch or PE qualification. Is it contingent about that condition as well, or does it only concentrate on the 4 or 5 years curricula? In order to become
the 4
full,
or 5
Washington Accord member.
Yeah, I think the 4 or 5 years is just.
Is it both the condition they have to meet?
The 4 or 5 years is just a suggestion, because that is actually the same time frame used to determine or evaluate the attainment of educational outcomes, or we normally call as PEO. But of course, it can also coincide with the training by the graduates in order to achieve professional status. Because in this case, if you compare EC, the professional competence, 13 professional competence, is actually aligned with the 12 or 11 graduate attributes in a way that it actually target for the same competence, but it's a more matured level. So it is possible, but of course it depends on the progress by the student itself. And also how the career path or the project they engage during their working life. Because not all project qualifies, or not all students qualify to be considered for the professional status.
Thank you, Professor Shahrir Abdullah, for your very valuable presentation, and which helped us to learn a lot and also clarify many issues. Now I'll move on to the second presentation of the first technical session. And the presentation will be made by Engineer Dr. Jamri Harun on incorporating complex problem solving and complex engineering activities in an engineering program. Engineer Dr. Jamri Harun is a senior fellow at the Department of Mechanical and Manufacturing Engineering at UKM. He studied at the Rensselaer Polytechnic Institute, New York. Dr. Harun's industry experience at Motorola, Malaysia, and at a flagship project of CIQ complex in Johor Bahru stretches over a decade. With a PhD from the University of Melbourne, he has research on vehicles, lab scale turbulence, and atmospheric turbulence. Dr. Harun is the head of mechanical engineering program at UKM and mentors the PE candidates at the department. He designed and built an automatic wind tunnel used to do experiments on turbulence studies with hot wire anemometry and particle image velocimetry. He received several research grants in turbulence studies as well as educational theme grants. Now I'd like to invite Engineer Dr. Jamri Hanon to deliver his presentation.
Assalamualaikum and good morning and good afternoon both. Thank you, Chairperson Dr. Muhammad Mahbubur Rahman. Thank you all guests, all participants. Now I would like to upload my presentation package. Sorry about that. My screen just start moving, so please bear with me.
It's okay, Prof. Please continue.
So how many minutes I have for now? Because now it's already 1:50. I mean 11:50 in my time. 30 minutes, right? Okay. I would like to deliver talk on incorporating complex problem solving, CPS and complex engineering activities, CEA engineering program in an engineering program. I'm the chair of Department of Mechanical and Manufacturing Engineering, Faculty of Engineering and Environment. I'm so glad to be here. I've been the coordinator for mechanical engineering programs since 2014, and that continued until 2018. So I've been doing this CPS and CA for far too long, and I haven't actually delivered any of this in maybe national, let alone international. So I'm so happy to share with you how to incorporate, how to implement such a thing. Okay, CPS and CA. For some of you, this might be too new. Okay, but for us in Malaysia, it kind of for some, especially for the program head or the coordinator, this is not too new. So towards the end, I really welcome, especially for the head of program, if you have any question. To make this really, you can say, fruitful, I actually based my presentation on the Board of Accreditation for Engineering and Technical Education based for the Bangladesh. Okay, I will not base on the Malaysian manual. Okay, because I think it will be more beneficial to you. It will be like more straightforward. You don't have to refer to many manual. So I went through it last night, and I downloaded a few things that are very interesting to me and maybe for some international people. Okay, and I start to realize that for Bangladesh there are 10 criteria as compared to 8 in Malaysia, and this is in chapter. I'm losing my mouse. Okay, mouse is back. This is in chapter 4. Okay, it says for the criteria, curriculum, teaching and learning processes, and it calls for the breadth and depth of curriculum and teaching learning activity should be appropriate for solving complex engineering problem in the relevant discipline, and it will go on and on. And in the second paragraph, it says the program should demonstrate culmination of program outcome at the level of solving complex engineering problem, preferably through a final year design project or capstone project extending over a period of 1 year. So let's keep this in mind while we are going through this presentation. And there is another one criteria. Just now we saw 4.6 and 4.8. So again, they were 10 criteria. And we have seen in Prof. Abdullah presentation, there are 12 attributes, okay? 12 attributes, and they're going to 11, and this is getting very complex because all IHL or universities in Malaysia, they are so used to 12 program outcomes, and now Washington Accord is coming up with 11, and going down, you know, the system in the university, then to the course pro forma and to the rubric. It's not so easy, but just bear with me. We will work on the 12th outcome. So we have engineering knowledge, be problem analysis, and goes on and on. And in the first one, we have complex engineering problem being called. In number 2, there is another complex engineering problem that is called, and it will go on and on. And to number 10, communication. Now it's different. It's complex engineering activity. Okay, so for new head of program, I think there might be some introduction that you need to be brief about. Again, I'm going through the BAETE manual. There is a statement there. In addition to incorporating the above listed PO, graduate attributes, the educational institution may include additional outcome in its learning program. An engineering program that aims to attain the above mentioned POs should ensure that each curriculum encompasses all the attributes of the knowledge profile K1 until K8 as presented in table 4.1 as included in the PO statement. The range of complex problem solving, okay, CPS I call it, P1 to P7, and complex engineering activities A1 to A5. Okay, so P is taking the letter from P problem, and then A is taking from the A here. They should be addressed in the program given in table 4.2 and 4.3. These tables are all in the BAETE manual. So I copy paste them. And how do they look like? In the knowledge profile, okay, this is not very new because we have seen in the previous slide by Prof. Abdullah. Okay, there is knowledge profile K1, systematic theory-based understanding, K2, conceptual-based mathematics, numerical analysis, statistics, so on and so forth. K3, systematic theory-based formulation. Sorry. K4, engineering specialist knowledge. K5, knowledge that support engineering design. K6, knowledge of engineering practices, technology. K7, comprehension of the role of engineering in society. K8, engagement with selected knowledge in research literature of discipline. Okay. Then we have range of complex engineering problem solving. Okay, if we count here, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. Okay, the first one, depth of knowledge required. There is a note here, P1 cannot be resolved without in-depth engineering knowledge at the level of 1 or more of K3, 4, 5, 6, or 8, which allow fundamental base, first principle analytical approach. Range of conflicting requirement. P2 involve wide-ranging of conflicting technical engineering and other issues. So while I am reading this, we must put into our mind what course we should align these CEPS first. Okay? For example, do we have this attribute range of conflicting requirement in our capstone project, which is the final year design project, or do we have this in year 2 fluids mechanic course? Okay, we should put this into our mind because it will not be appropriate if we choose a fluid mechanic course which don't have conflicting requirement. Maybe, I'm not sure in each country if there is such a thing. Okay? So let's just go down into the table. Depth of analysis required. P3 have no obvious solution and require abstract thinking. Familiarity of issues. P4 involved in frequently encountered issues. Extent of applicable codes. P5 are outside problem encompassed by standard and codes of practice for operational engineering. Stakeholder involve diverse group of stakeholder with widely varying needs. Okay, so we have to ask ourselves, okay, do we involve stakeholder in, for example, year 3 course, for example, engineering economic? Do we really engage stakeholder? Do we engage industry? And then 7, actually, this is number 6 together. So there is the line here that need not to be here. So this is number 7, interdependence. 7 are high-level problem, including many component parts or sub-problem. So having introduced some of these keywords and their explanation, then we should put into our mind into the further discussion on this. Okay. Another statement in the manual, the program should describe the process involved in defining and refining the PO. Correlation between the course outcome, CO and PO should be demonstrated through the mapping of CO onto PO. Okay, we have done mapping many times, CO to PO. I think all head of program, all coordinator have done this too many times, so this is not too new. The way in which each attribute of the knowledge profile K1 to K8 is addressed in the curriculum should be demonstrated through mapping. So now another level of mapping, right? Knowledge profile mapping. The program should also demonstrate how each attribute of the range of complex engineering problem P1 to P7 and complex engineering activities A1 to A5 is incorporated in the teaching and learning assessment. So it looks like there are 3 levels of mapping. So it's not easy for first timer to do this. Okay? And I'm sure that every IHL, every university, they have their own approach. I'm sure given explanation to the auditor, if you make the auditor understand what you are doing, then there shouldn't be any problem. But let's just say that now that the country and then the university is in the maybe probationary stage. Okay, let's probably do it properly so that the entire maybe university, the entire culture is within grasp, within the same understanding. Range of complex engineering activities. Actually, this should be after table 4.2. So I just made a small mistake here. There is level 1 range of resources. What are resources? Equipment, money, people. Level of interaction require resolution of significant problem arising from interaction between wide-ranging or completing technical engineering of or other issue. Innovation, innovative creative use of engineering principle and research-based knowledge in novel way. Again, same thing that we should do here. Okay? Ask ourselves, does our course in year 1, okay, for example, CAD, okay, drawing using 3D, using very fancy software, does it have innovation? Maybe there are, okay, in year 1, maybe very aggressive university, they want their CAD course to produce 3D modeling that has maybe motion or dynamic kind of simulation, and they put some innovation feature in that. Okay? Probably yes, okay, but generally innovation shouldn't be aligned to courses in year 1 and year 2. Okay? And then next, consequence of society and environment, A4, okay. CEA, A stand for activities have significant consequence in range of contexts characterized by difficulty of prediction and mitigation. Familiarity, if I can extend beyond previous experience by applying principles-based approaches. Review of PO, this is what Prof. Abdullah mentioned just now. They are going to like embed PO7 to some other PO. So at the end, it will be 11. We haven't done that, okay, in Malaysia. All university now still with 12 POs, and in fact, many universities, they are still sticking up to the old program outcomes. That is PO9 is communication. They are crisscross here, okay, and there's another crisscross to PO11 to lifelong learning, and PO12 to project management. So I think we are like maybe 2 years behind. And then knowledge profile, this is a review again. We have talked about this. So let's just review 1 or 2 so that we know the keywords there. So knowledge profile 1, science, 2, mathematics, so on and so forth. Now we go down to business. This is real business that all the program head have to have to bear. Okay, the panel will come. Okay, from BAETE, they appoint a panel, 2 panel, and 1 head of panel. If there are so many programs, then there is a head of delegation, and they review your program, and they say this is good, your lab is good, your ratio between the staff and student are good. Okay, remember 10 criteria, 1 criteria is out, you get 1 concern, right? That's normal. Okay, when you got 1 concern, you will not get full accreditation 5 years or 6 years. I'm not very sure in your country. Okay, this is a real comment. Okay? At the moment, from detailed documented evidence and interviews with IHL stakeholder, the panel concluded that the code, I have to withhold the code. Okay, so there's a code here. I cannot show it. This is on introductory economic for engineering course, now lacks important engineering components such as knowledge for industry scale plant design, procurement, plant management, cash flow, depreciation, and bank loan assessment. When also noted that this existing course is not strong in engineering economic and is presently not incorporated in the 3rd year or semester 5 and 6, which would be of great help to further strengthen the student confidence on engineering economic knowledge when carrying out the IHL Capsule Integrated Design IDP in final year. The course is presently not being taught by we make a great deal of it. Okay, there must be a professional engineer teaching the course. Okay, professional engineer means those who have a certain years, and there are very stringent requirements to apply for and to get approved for the interview. That is a requirement that each program in Malaysia must have a minimum of 3, and the requirement is going more stringent now. IHL is committed to further strengthening the complex problem solving and complex engineering activities component into the existing material engineering curriculum to accommodate the new expectation of the revised. Well, that's back to 2012 manual, but not much have changed. Okay, there are changes, as Prof. Abdullah mentioned, keep changing after we have the 2020 manual. They are coming up with 2021, right? But we got the idea. Okay, complex problem solving and complex engineering activities are being measured, okay? Being tracked. So the panel saying that no, this is not good. You are not putting enough effort into CPS and CEA. So what happened? Okay, so this is a concern. This is a concern, and you will not get the full accreditation for this. Okay, simple. Okay, there is no complex problem solving CPS and complex engineering activities. It sounds like it is in the sky. Okay, what do we have to do about this? Okay. Okay, how does it relate to curriculum? Do we relate to general subject, industrial placement, course-specific engineering subject, CPS, elective, design project, final year project? Actually, it can be related to all of this. But for my program, the mechanical engineering program, we call this culminating courses. Okay, we align them to design project or the capstone project in year 4, semester 7 and semester 8, and also the final year project, the also semester 7 and semester 8. And why we don't choose elective? Because it's so hard. This student take this elective and another take another, right? How do we measure at the end of the day? We don't have a good system to track the student who fail and who went through. And industrial placement, how do we control them? General subject, mathematics, ethics that we combine with different program. It's very hard to control them. So we want something that we can control. Right? We change the rubric, and then straight away we measure the attainment. Continue on from here. All the head of program, they are aware of this, how to map CO to PO. So, for example, we have engine mechanic in year 1, and that PO is aligned to PO. It measures attribute PO1, PO2, and 4, so on and so forth, right? Just to give you some idea. And after that, okay, and that's the same. And bear with me because the name of the courses are in Malay language, but you got the idea, okay? So engineering mechanic just now, mechanic kejuruteraan, the CO, these are real score, okay? There's no like confident material here. It was like in maybe 4 years back then, okay? The students score 61. Okay, this is related to the question regarding what is the minimum minimum requirement, right? 50% that we mentioned just now. So that depends to the country. So we put here 50%, and anybody with less than 50% mark, they will have like here we just put it for the sake of maybe our eye, we make it red. Okay, so this is like a sample only, okay, just to make you understand. And how about the PO? So the PO is scored here. So we have a general rule of thumb: 1 CO is mapped to 1 PO. Okay, we don't want too many complex, 1 CO is split into 2, 1 PO is split into another 2, and that's very complex. Okay, now how do we map CTS and Ctea into our program, right? Maybe you have done it. If you haven't done it, then this is an approach that you can make use of. This is some general guideline. Okay, there are 12 PO now going for 11 PO, and then all PO. Okay, there are a certain knowledge profile only that it can be attached to. For example, PO1, K1, K4, and shouldn't be attached to K5, for example. Okay, so now we were talking about CPS, right? Engine problem. So PO1 until PO8 can be attached to engine problem solving, okay? Whereas PO9 and PO12 can be attached to engine activities. So don't make it complicated that you have like 1 PO in one course, say engine mechanic PO4, and then you want to measure the engineering activities there. Okay, so they will not make the auditor happy about it. They're thinking that you need some kind of like process of learning or something like that. So make sure that this general rule of thumb we comply with. Okay, and then I'm coming back to Malaysia now. Okay, and in fact, this particular slide, I take it from the EEC slide. I believe it was prepared by Prof. Kamaria or Dr. Siti, now the director of EEC. The attribute complex broadly well-defined engine problem. There are 7 items there. Actually, we have seen this kind of information earlier on. Okay, 7 items there, but there are some trick here. Okay, so out of the 7, we were talking about this, right? Which one do we choose? Okay, so let's start. Choose P1 for your capstone. For example, we choose the project because that's easy to measure the complexity, right? So for the capstone, choose P1 and some other 2. Okay, some other 2 and above. That is P1 and above. So you can choose type of analysis and familiarity of the issues. Okay, so now you have 3 that is suited to the complex engineering, complex problem solving. And then we want to do the same for the complex engineering activity, CEA, and they are A1 until A5. Okay, range of resources, that is people, money, machine. A2 level of interaction, A3 innovation, A4 effect to the society and the environment, A5 familiarity. So what do we choose now for CEA? Okay, so we can choose some of these. Okay, we can choose 3, but although I put here some or all of A1 to A5, but do not make it too complicated. Okay, just choose 3 that will be good enough. Just choose 3, because otherwise it is hard to measure. Okay, so this is the sample. This is capstone that we choose. Okay, capstone integrated design project standard EAC 2020. We put in the course pro forma. It involves complex engineering problem and design system component or process integrating, culminating core areas and meeting specific needs, appropriate consideration for public health and safety, cultural, societal, project management, economy, and environmental consideration where appropriate. The ITB are multifaceted assignment that serve as a culminating academic and intellectual experience for students, typically towards the end of an academic program or learning pathway experience, involve students working in group to deliver and assess many relevant POs to the integrated project. Okay, so we put this as the, basically the information for the course, and so that we are not running away from what we committed the cost to the student and also to the basically to the industry, because they can access this. So again, some of the course, some of the program at the faculty. Okay, there are 4 programs for mechanical. This is the last one, and as you can see that for the mechanical, they are 1, 2, 3, 4, 5, 6. There are 6 course outcome, and those 6 course outcome are mapped to 6 PO. And one of the program, they decided, okay, they have the entire PO. Okay, that is from PO1 until PO12. For my recommendation, do not make it too complicated. This is just fine. Okay, just use 6 or 7. Okay, 8 is max already. Don't do more than that, otherwise you are making it too complicated. Okay, for IDP, for capstone, I think 4 is too little. Okay, because in year 3 you already have a few courses that you measure the 4 PO out of it, right? So capstone is much more complicated, right? So something like this is appropriate.
Dr. Harun, I hate to interrupt, but I'll just kindly remind you that you'll have 3 more minutes left on the presentation.
Yes, sure. Thank you. And again, the CO and PO. Okay, I have this slide showing that how do we map the CPS to the PO. So this is how we do it. Complex problem solving for our capstone. This is our capstone. It's mapped to PO2. Okay, CPS 1 to CPS 4. And for the CEA, we have FYP2 or the final year project 2. Okay, we have the CEA over there. So this is how we are doing it at UKM at UC Kebangsaan Malaysia, and put it into rubric. Tell the lecturers, have like meeting with them, like a workshop or something like that, and tell them what CPS are, what CEA are, and make sure that this is put into the delivery of the course. Then it will be implemented. Without rubric, it is as good as never implemented. Okay, so these are how we conduct the course. We mentioned to the student that there are SDGs that are associated with this. So at least we make it sound complicated. Maybe it is not so complicated, but we make it sound so complicated. These are sample project. Sample project again, we invite actually external evaluator. Okay, it will not be just us. Okay, there are like 6 of us lecturers, but every year we ask industry people, and they are not engineer, head of mechanical, managing director here and there. So they quickly give us some feedback. And for capstone in UKM mechanical are divided to 7 semester and 8 semester, where the 7 is the design and the 8 is the manufacturing processes, without going into much detail. Okay, so yes, that's my presentation, and I hope it makes sense to you. Thank you.
Thank you, Dr. Harun, for finishing right on time. I understand it was quite difficult for you because you had a lot to say, but whatever you have said, I think we learned a lot. Now I'd like to open the floor for question and answer session. And I'd like to suggest that you can raise hand and then we can give you the floor, or you can type your question in the chat box so that we can see and then give you an opportunity to read it, or I can read it for you. Now we have already a question from Dr. El Sheikh, who was asking, or who was requesting you to shed light on the difference between the 3 terms: complex problem, difficult problem, and high level thinking problem. So if Dr. Harun can respond to the question, please.
Okay, there are complex problem, difficult level problem, high level problem, and difficult level problem, or something like that, right? Okay, there is a slide, I think, in here. Okay. Okay, there are few criteria in complex problem. Okay, so those criteria consist of these 7 items. Okay, there are depth of knowledge required, range of conflicting requirement, familiarities of issue, extent of stakeholder, involvement of conflicting requirement, interdependence. Okay, so this has been, I guess, has been discussed at a high-level meeting at the Washington Accord meeting or something like that. Okay, there are minutes of meeting out of that. Okay, to be frank with you, the other terms, okay, which are the high-level problem or difficult problem, I'm not sure to answer them, because maybe those are not the term that are being discussed at this Washington Accord meeting. So there are no like definition or something like that. I guess somebody can help me also to maybe complement of what I have mentioned.
Thank you. We can also receive question in the question answer box as well as in the chat box. So we have one question in the question answer box from Bishojit Shaha. I'll read the question. Is it necessary to have complex engineering problems in fundamental core courses to meet the statement of PO1?
Yes, you can put the CPS in year 1 and year 2, but more importantly, you should put it in year 3 and year 4. Okay, and you have to divide this basically these 2 first year and 2 second year. Okay, and then CPS, you should measure them for the culminating courses. Okay, the culminating courses are not all of the second part of the year. Okay, these culminating courses are only like as mentioned before, the capstone, the FYP, maybe the integrated project. Okay, to measure, however, this is my recommendation. Okay, to measure the complex engineering attributes, okay, CPS, you should only choose like 8 to 10 courses only. And although you have already put complex engineering problem in year 1 and year 2, but for the purpose of calculation, you should not collect it from year 1 and year 2. You can do it, but you shouldn't collect it to be like the final representation of the student when they are graduating. Okay, it should come from year 3 and year 4.
Thank you, Dr. Harun. I hope Mr. Shaha has got his answer. Now we have one more question from one of our colleagues, Dr. Hani. And the question says, is it necessary to assess the complex engineering problems and activities using rubrics-based scoring? If not, how we can assess it?
Okay. Definitely, when you assess, it must have a rubric, because without a rubric, I'm not sure, even for non-CPS and CEA, I'm not sure it can be done, okay, for simple, measurement of PO1 to PO5, for example, okay, for year 1, for my program at UKM, we have a rubric for most of the evaluation, most of the for the grades, for the assessment. So we have then. So let alone for those that we measure the CPS and CEA achievement. So it must have rubric.
Yes, sir. Thank you. I think we can afford time to have, we have 3 minutes. So we have one more question, and it's from an anonymous attendee. Is that all right? Okay, thank you. So his question says, is there any example of CEP?
CEP, right? Complex engineering problem. Okay. I believe, okay, because I have a short discussion with Prof. Mazharul. Okay, when I read the manual, I believe the CEP actually referred to the CPS. Okay, complex engineering problem, CEP, is referring to the CPS. Okay, so in manual, it's quite clear that we only have one terminology, CPS. But when I look at the BAETE manual, sometimes they call it CEP. So I believe that is referring to CPS, same thing.
Thank you, Dr. Harun. Okay. It was a very lively session with a lot of queries and responses on how to integrate integrate the problem solving and the engineering activities in the curriculum. With this presentation, the technical session number 1 ends here. I should like to thank the 2 presenters for the valuable insights they provided on engineering education, and the rapporteur and the session coordinator. I also like to thank the organizer, as I'm not an engineer. My background is architecture, and we have different accord, but there are many similarities, of course, and I learned a lot. Before closing, here is a small housekeeping announcement. We'll resume our next session at 1:30 after the break for prayer and lunch. And thank you very much, and thank you all. Assalamu alaikum.
Thank you so much to you. Bye-bye. Assalamualaikum.